All right, so recording has started, and I will start sharing my screen. Just 1 second. Sorry. Okay. So this is the case study again. We answered most of the parts, but again, I will go through it very fast. And if you remember, we implemented this class before. So I'm just sharing with you the code and everything. Maybe we need to add some other points here, explanation. So we will start over again, start from the beginning. First of all, the idea is to develop or to write the code that represents the student as a class or an object. And we applied most of the principles of the classes or object-oriented programming on this class. So let's try or let's go through it again. Here we may need to add something else, which is the class diagram. And if you remember, we said the class diagram, we need to, we didn't go in deep in class diagram because you will cover it in object-oriented design, but it's important to know about it. So here, let's think of the student as an object. First of all, as we said, we need to implement or let's think of the student as an object. And if you remember, in the class diagram, we said I can remember I can represent the class in three parts. First, the name will be student, then the attributes and the methods. All right, and here the attributes has three different access specifiers, which are public, private, and protected. Okay, so at the beginning, of course, we will add name as an attribute, ID, GPA, and any other attributes. Specifying the type of or the access specifiers, this will be covered very soon when we want to encapsulate or to hide the information. So if I put, for example, the name, like I put the plus sign, that means the name is public. All right. If I put minus sign, that means the name, the ID is private. Okay. So it depends on your design. Mostly we use all the variables or we design all the variables as private. But here in the access specifier and the methods, these are the name, as we said, the name of the class, then the attributes, and then the methods. Okay, you need to make it public. So the first method is, for example, info, and we usually, I told you, if I ask you to suggest any non-specified method, then info, which prints all the attributes. All right, you can add any other method like get name, which is, as you remember, we called it getter, or we called it accessor. All right, and for example, also set name, we called it setter, or also we called it mutator. All right, remember all these principles. Now, after this, I can convert. If I give you the class diagram and ask you to represent the class using this, then you will come and write like this. First of all, student is the name, should start with class. So I will write class here, then the name of the class. After that, I will check the access specifiers. Here, at the beginning, we considered everything is public because I don't now. I'm just giving the attribute, but later we will change this to private. Okay, so but in your case, when you design, when you can find, for example, name is public, then you will put it as public string name. And here, for example, you find it as private, then you write private ID. Now, if GPA is also public, you don't need to write public again. Just put it here. So, because when you write public, everything comes after public is public, and until I get another specifier which specifies the type of the access for the other variables. So here I put everything as public, and we said the type of the variables is very important also. Here the name is string, the specialization is string, and the ID is integer. And again, not necessarily to be integer, it might be string, because not all the universities or the colleges use numbers only in like in your case to 2021, 16, etc. Some universities add characters like NU 200, etc. Okay, so it might be string also. No problems. I will accept both. Now define the student class. This is what we define. Again, we made it public because this is the first step in the implementation. Later, we will change it to private. Okay, so string, name, specialization, etc. Now, how to use this? I defined student st1, also implemented this, student st1 and student.name. Now you can access. Why? Can be accessed. Why? Because it's public. Okay. This one also will not generate any error. Will be accessed and it's accepted. Student specialization, student.id, see out student.name, then it will print the name. You can use now the the attributes of the object as any variables. All right. So in this example, the attributes are public, which means that they can be accessed directly from outside the class using the dot operator. Now the methods. The methods are the functions that the students can do or can be applied to the student. Okay. Attributes such as accessing private or protected attributes, yeah, all right, setting and getting attributes from the method, printing information, calculating, perform some mathematical calculations, like calculating the attendance, calculating the GPA, etc. All right, so here if you can see, till now, public, we didn't change anything. We don't, yeah, we declared a function called void info, which prints everything related to the students. All right, so let's see here. Now, in this case, since you have info, of course, we don't have constructor yet. So I kept it public. All right. So void info will print the information, like student name is name, student specialization, ID, and in the main function, when I declared student, I can call student.info, which will print the information. The execution will be directly. I can show you the execution. You can take it. Right. So what you can do now is just copy from the Word file and see the execution. Now I'll build it. All right, successfully finished. Then I will run it. Okay, so if you can see in the main function, I don't have any print instruction, but eventually I'm printing all the information when I called, or I printed all the information when I called st.info. All right, so let's continue with the, all these were implemented before, and now we talk about the constructor. Now, actually, in one of the common questions is that it's mandatory for every class to have constructor. Actually, it's not. Now, if you get a question like, is it mandatory that every class should have a constructor? Actually, the answer is no. It's not mandatory, but it's part of the classes. All right, it's not mandatory. You can, like in the previous classes, these classes or this class, this example, it was without a constructor. But usually we use the constructor to initiate the class. All right, and the features of the constructors, we discussed them. We said it should be public. All right, it's public. Then the name should be identical to the class name and should return no value. Okay, or doesn't return any value. Now, you can do whatever you want inside this, because this will be executed when you declare a variable. Like when I declare a variable student S1, okay, it will come directly and search for the constructor and execute it. All right. Here we prefer to use this to initialize the variable. Now, if I have constructor, then I would recommend to change the public into private, because I can initialize it now. So string name, string sp, integer id, name, this name of the class is equal to small name from the function with a small letter, specialization equal sp, and id equals small letter id. I initialized it now. All right. So what we'll do, I suggest now to change this to private. Okay. But if I change it, I'll get error. Why? Because I should have public before the class. All right. So now if I use, for example, st1.name, I'll get error. All right. Or str.specialization, I'll get errors. And integer id, st1.id, also I'll get errors. So the only way that you can access them is through info, and of course initialize them through the constructor. Let's also take this code and show you how to execute it. Right, so yeah, it's private now. Okay, I will build it. All right, then run. Okay, well, although I didn't, if you check the main function, I didn't use any setting. I only called the constructor. So at this moment, let's go to Word document and explain it. At the moment when I declared a variable or an instance st1 of type student, and I write like this, student of Ali MIS and 1, 2, 3, 4, it will search directly for what? for the constructor, and it will pass this to name and MIS to SP and 1, 2, 3, 4 to ID. Then it will initialize the class. All right. Now encapsulation, when we change the meaning of encapsulation is to put everything in one entity. All right. Encapsulation means I can put everything in one entity. Now, if you saw that the student now includes everything, the name, the ID, the specialization, the GPA, if I want to add more information, the initialization, everything is in one element, which is the ST1 in this case. All right. Usually also, as we said, uh, it's preferred and sometimes it's mandatory to keep the variables or the attributes as private. Okay. All right. Uh, Abstraction. Now we talked about abstraction and we said sometimes you don't need to know, or the user doesn't need to know all the details. Just like when you are using your cell phone, you don't need to know what's going on when you send a message. All what you need is to type your message on the keyboard and press send. The car driver doesn't need to know what's going on in the engine, in the gearbox, in the transmission system, etc. He or she doesn't need to know these things in order to drive the car. So the same thing in classes. You don't. The user sometimes doesn't need to know all the details or every detail in the code that or the program that he or she is using. That's why we made it, or we can make it abstract. Abstract class here, if you can see the first way of abstraction is the virtual void here to define a function. If you remember, I told you if I made it equal to 0, then it's a pure virtual. When I'm talking about pure virtual, that means that every class that inherits or every subclass from this class should define this function inside the class. All right, let's see, for example, here I have class student. It's inherits or a subclass of ABS, abstract student. Then if you don't define the function, you will get errors. All right, nothing will be changed here. It has the private the name, the ID, the specialization. I added the GPA also here. It's okay, float. All right, and here the constructor. Okay, and void info and other things. See now the name of this function is honor list. You know, in the college, for example, or another college, the honor list, if your GPA greater than a specific number like 80 or 86, then your name will go to the will be included in the honor list. So here I defined the honor list here. If GPA greater than 80, see out, you will be on the honor list. Or of course, otherwise, you can put like else, sorry, you will not be included in the honor list. All right. So if I don't declare this, or if I don't define this function, then I will get an error. Also, I don't know if I can copy it because it's crashed a lot. All right, so Control C. Yeah, okay. So this is the virtual void honor list equals 0. Of course, if I didn't make it equal 0, then it won't be mandatory. All right. That means the subclasses can define or can ignore defining the function. So here, if I want to, let me just add here another else out. Sorry, your name will not be listed. All right. MDL. All right. So if I run this, it's supposed I supposed to get a message that your name will be listed in the owner list. Okay. So run. Okay. Very well. So here, student Ali and the GPA is 87.32. Ali, you will be in the honor list. All right. So here, let me just add some space. Also here, I'll add the name. So okay. Now, for example, if the GPA is below 80, let's say 79.9. All right, and let's run it. Okay. Also, the information and Ali, sorry, your name will not be listed. Okay, so this is the abstraction. That means I have to force all the subclasses to have a specific function. For example, in the previous example that we discussed, we talked about the shape. And we said, for example, that rectangle inherits from the shape everything, and also it has to declare the area. All right. Okay. So this is the abstraction. Now the inheritance. In class diagram, for example, I have here a student class diagram. Student. And I have attribute and method. Then the inheritance is represented by an arrow, all right, like this. Okay, that means inheritance. Okay, so in inheritance, the subclass, this is the superclass, all right, will inherit everything from the class as if they are its own attributes and attributes and methods. So here we saw the inheritance, by the way. For example, here I have student abstract class, and I think I have another class, which is, yeah. Okay, now let's go step by step here. This is the abstract class, all right, and we explained it. This is the student, all right, with all the attributes and the methods. And remember that we changed this to be private, okay? So I can access them through setter and getter, and this is the student. Now I'll declare, or I'll define a new student who is graduating student, okay? What's the difference between the student and the graduating student? The difference is number of remaining hours, right? A graduating student doesn't mean he or she has graduated. We call it graduated student. Now graduating. Graduating means the person or the student who is in the last semester. All right. And usually we consider the student to be graduating when he or she has 18 or sometimes 21, 18 credit hours to study. All right. So all what we have here is remaining hours. Now you may ask me, I have declared a full or a new class only for remaining hours. Yes, because it has taken everything from the student, the name, the ID, the GPA, everything has been taken from the student. So here uh, in the subclass, now if when you create the constructor graduating student, I have name, specialization, ID, GPA, and remaining hours. But if you can see, all these are not the graduating student properties, right? Although it has inherited them from the student, but it doesn't have them in the class, in the code. So what we will do here, we should pass these things to the original or to the superclass, which is the student. The student will declare them and will initialize them. All right. All what we need here just to have the remaining hours, initialize the remaining hours. Now, if you can see here, student st1, student of Ali MIS123, etc. Student.info, student.honor list, and then I have graduating student, GS graduating students with information. All right, and let's just copy this. It's a bit lengthy. All right. Okay, so if you can see, this is the implementation. This is what you can do also. You just copy and paste it and follow the instruction one by one. And here, if you can, let's see what we have. We define the student, all right, the class, abstract student. This is the class. Then we defined the student, okay, with all the information. Now, I define graduating student as public inherits from the student, all right? So here, if you can see, private integer remaining hours, only it has remaining hours, and the rest are taken from the student, right? Here, we pass them. Now, if I execute this, all right. Okay, so this is the first student. Okay, Ali, specialization MIS 1234. The GPA is 87.321, and Ali will be in the honor list. And the other one is Ahmed, specialization CS, ID is 456, GPA is 66, but we didn't print the remaining hours because why? Because here in the original or in the super class we don't have the remaining hours. All right, so you can print them separately. All right, so this is the inheritance. Of course, there are several types of inheritance. As we said, we have different types and we have different modes. When we talked about inheritance, please go and read the notes. We said the modes are public, private, and protected inheritance, and the modes are single inheritance, multiple inheritance, and so on. All right, so everything was covered in the lectures. You can select. Now this is a single inheritance. If you go there, yes, here. Okay, what's the mode of inheritance? Of course, here you can define the mode either public or private. It's up to you. Okay. Here, for example, public. or private or protected. This is the mode, okay? But the type is single inheritance. Why single? Because it's only one inheritance, all right? Okay. The other part, which is very important, and we explained it, is the polymorphism. Polymorphism, simply it means using the same function, okay, but with different number and or type of variables or parameters. Okay, so here we don't want this. It might be a bit confusing. Okay. So here, if you can see, I have the let's see what we have defined here. The abstract is still the same. Student inherits from abstract and specialization, ID, GPA, initialization, info, set name, get name. Everything is almost the same thing. All right, and okay. Yes, here we define something called next semester. All right, this also here. So I defined next semester for each class, for the student and for graduating students. Listen, this is very important. Now, when I define a graduating student, okay, and write dot next semester, all right, like here I defined it. Where is it? This is next semester. This is in the student. What's in the next semester? See out, you need to register courses next semester. All right. So this is what it will do for the student. Void.next semester, see out the name of the student, yeah, the name of the student needs to register courses in the next semester. But for graduating student, he may not or she may not need to register. That's why it works in different way here. All right. Next semester, for example, see out name needs to take training. Okay, so the regular students, the ordinary student, can register courses, while the graduating students needs to take training. See, actually here, the same name, right? The function has the same name in two different classes, but with different meaning. Now, if you can see here, I have the class student, okay, and I have method next semester. Okay, also I have another class which is graduating student. Okay, inherit okay, inherits things from student, but I also has next semester. Now when I declare graduating student GS, for example, all right, equal graduate, etc. This is, but when I write GS dot next semester, it will go first to the subclass. If it finds the subclass has a function, then it will execute it. If it doesn't find it, then it will jump and go to the original class and execute the original function. Okay, so if you write, if you want this, that's why we call it overriding. Overriding means although I have function here, let's call it f1, and I have here f1, all right, but when I write gs.f1, it will come here. If it finds it, it will execute it, and that's it. If it doesn't find it, it will just, for example, gs.f2, and I have here F2, and here I don't have F2. All right, then it'll come here, search for F2, doesn't find it, go to execute the original one. This is the way that it will execute the sorry, what's happening? Yeah, this is what we call the polymorphism. All right. Of course, we discussed the types of polymorphism. Please go back to the lectures and check all the details about polymorphism. I will execute this one, and I'll let you execute it and see how things are running. Now, if you can see here, I have the student abstract. Of course, I have the first class, which is abstract on our list. All right. And the student, which has the features that we talk about, the attributes and the methods, and I have graduating students. And here also, let's just execute it and see how they will work. All right. Okay, so if you can see here, student name is Ali, specialization, Ali needs to register courses, Ahmed needs to take training. Why is that? Because here I defined a graduating student, GS, and I used next semester. If you can see here, I used next semester for both objects. For ST1, next semester, it went and searched for next semester and found that the function next semester is cout the name of the student needs to register course next semester. While for graduating student, okay, this is graduating student class, okay, it's the implementation is need to take training. So I will remove info, okay. This is the regular students, Ali, MIS 1, 2, 3, 4, etc. ST1 next semester, and graduating student, graduate student, Ahmed CS, etc. and GS next semester. And the execution will be different for every object. All right. So Ali needs to register courses next semester, and Ahmed needs to start taking training. All right. So I'll share this Word document with you, and I want you now to start implementing this. Not this one. Okay, just let me find the. Okay, I want you now to start recording. Sorry, not recording. Start implementing it, and I'll stop recording now, just in case if you have any questions, you can ask directly, and